got a couple minutes before class starts, so I'm going to try to record a super fast unit vectors video. Okay, so let's say we have this vector, an algebraic vector, 2, 3. Let's draw that. So it's like over 2, different color. So it's like over 2 this way, and then it's up 3 for our y component, and there's our vector. Okay, so, actually, changing this up a little bit, I'm going to go with my favorite 3, 4, just in case I have to do any math, and I can handle it. Alright, 3, 4. Okay, new vector. So there we go. So let's say we wanted to represent this as a unit vector instead. So remember I defined these guys, like I hat and j hat. So I hat I defined as a vector equal to 1, 0. And j hat is like our y component unit vector, and it's 0, 1. So that just means these guys always have a magnitude of 1. So I hat is just 1 unit this way, and then j hat is just 1 unit on our y component. So you can actually represent any algebraic vector using I hat and j hat, and it's going to be useful in the future. So let's say we wanted to represent this S guy using I hat and j hat. So if you think about it, you're just kind of thinking how many I hats will go along the bottom here. So I hats are unit 1. So if they're unit 1, it's pretty much taking 3 of them to get across. So if we wanted to write this vector using unit vectors, we could actually just say we need 3 I hats, or 3 times I hat. And since I hat just has a magnitude of 1, 3 times 1 would be 3. Plus, instead of a 4, we're actually going to use the j hat notation, and since we would need 4 j hats, 1, 2, 3, 4, because they're all magnitude 1, so if we do 4 times j hat, this just means we have 3 vectors that are 1, 0, and we have 4 times j hat, which is 0, 1. So if we were to simplify this expression, we can actually just multiply 3 by this vector. That's like scalar multiplication. Remember we said if we had a vector of length 1, just say that's a vector of length 1, we can multiply that by 3, and we just have 3 times that vector. So that's just called scalar multiplication. And that's what we're using here. So we actually are just going to turn this into vector 3, 0, because I'm multiplying it by 3, and this vector would become 0, 4. And then remember we talked about, adding vectors, you just add their x components. So like 3 plus 0 would be 3, 0 plus 4 would be 4. So I just proved that 3 I hat plus 4 j hat is actually just equal to 3, 4. So you can just turn any vector into a unit vector. Boom. By using I hat and j hat. It's pretty straightforward. And it's going to become useful later. So let me show you another one that we'll be able to use so fast. So let's say we had vector A. It's going to be -3, 5. If I wanted to turn that into a unit vector, I'm just going to say -3 I hat plus 5 j hat. Super fast. I can do it if I have 3 space too. So let's say I had vector B. That was 2, 1, -7. So I just added another plane. So we said I hat was 1, 0. We said j hat was 0, 1. But if we're going into 3 space, we're just going to add a z. So x, y, z. So this would just turn into 2 I hat plus j hat minus 7z. Oops, minus 7 k hat. So that's just 2 and 3 space. So we can turn a Cartesian vector, algebraic vector, into a unit vector just by doing that. There's one other tricky component about unit vectors, and that's just talking about magnitude. So, and direction. So like, say we had this vector here of length 5, magnitude 5. So that's our vector. So say we wanted to turn this guy, let's say that's like 30 degrees or something. Say we wanted to turn this guy into a unit vector. So remember, a unit vector has a magnitude of 1. So unit vector has a length of 1. Just like our I hat and j hat was just 1, or 1 on the y-axis. Okay, but if we're talking about this kind of vector, well, this is length 5 with a 30-degree angle. Let's say we want this to become a unit vector. So we can actually turn any vector into a unit vector. So we're saying instead of 5, we actually want this to be a length of 1. So we're trying to turn this vector into having a length of 1. So we're turning it into a unit vector. So to do that, okay, wait. Yeah, I'm just gonna restart this. Like, everything I said was right, but I actually just wanna use the same question. So our unit vector 3, 4, or sorry, our algebraic vector 3, 4. 3, 4. So I wanna do this a different way. So the magnitude of that vector is 3 squared plus 4 squared, square rooted, which I already know is going to be 5 because I've used that vector 15,000 times. Let's just say, instead of doing it the way I was doing with the I hat, j hat, k hat, which is way more useful, but there is another way. If we want this to have a magnitude of 1, we're pretty much going to have to divide our components by that magnitude. So I know this is a bit weird, but another way to do unit vectors, having the same, well, this is a different way, would be to represent this vector as 3 over 5, comma 4 over 5. So I'm just dividing the x and y components by the magnitude of the vector because now I have a magnitude of 1 for my unit vector. So if you look at now our unit vector s, if I wanted to calculate the magnitude of that vector, so 3 over 5 squared plus 4 over 5 squared, so 3 over 5 squared would be 9 over 25. 4 over 5 squared would be 16 over 25. 9 plus 16 is 25. So if I'm adding fractions correctly, 9 plus 16 is 25, and we keep the same denominators, so 25 over 25, which would equal 1, and the square root of 1 is just 1. So I've just created, by changing this 3, 4 Cartesian vector into 3 over 5, comma 4 over 5, I've just turned this into a unit vector now. So this now is 3 over 5. Oops. 3 over 5, 4 over 5. So I don't know if we're ever going to use this. Maybe it'll come up in your future physics classes or math classes, but it's just a different way to look at unit vectors. So now our magnitude is 1 for this unit vector. Yeah. I think the thing we're going to be using all the time is I hat, j hat, and k hat, and then simplifying expressions with these things. Okay, the end.